Hi guys, welcome back to my YouTube channel, and today I'm recording 5070 theory paper of May June 2018. This is paper 2 of Cambridge International Examination. Make sure you check out my part 1, 2, 3 and 4 in which I have solved the entire section A. Today I'm continuing with section B. To see the solution of all of these questions, you can check out my previous videos. I'll put the link in the description below. So let's start with question number 7. Sulfite is an ore containing compounds of zinc. One of the compound in the ore is zinc sulfite. Calculate the mass of zinc in 30 tons of zinc sulfite. The question says that we are supposed to find the mass of zinc. And the total mass of zinc sulfite is 30 tons. So for this, first of all, we'll find the percentage of zinc, and it is around 67%. Then we're going to find the mass of zinc, for which we are going to do total mass or the percentage of zinc into the total mass. So we will do it in this way. 67 upon 100 into 30 tons. For this, the answer would be around 20.1. Now, how do I know the answer should be written to 1 decimal places, 2 decimal places, or significant figures? To what number of significant figures it should be written to? So for this, it is like a very simple technique. You are supposed to look in the question if there is something that is of the same value. For example, mass of zinc, and here we have mass of zinc sulfite. We have mass of zinc sulfite, so both of them are masses. When we talk about masses, they are the same quantity, and as it is given in the same question, also in the same part, even part actually doesn't matter, but if it is given in the same question, make sure you see at the value and you see that how many significant figures it is written to. Once you look at it, you can quickly get the idea that I need to write it to 1 decimal places or 2 to 3 significant figures and all that. So make sure you look at the values given in the question in case you forget. Otherwise, mass is usually written to 1 to 2 decimal places. Usually it is written. But in case if you forget, so make sure you can use this technique, keep this in your mind. Part B. Zinc sulfite is heated in air, zinc oxide and sulfur dioxide are formed. Construct the equation for this reaction. So as we can see over here that zinc sulfite is heated in air. When we talk about air in any other question of this chemistry paper, of our code or any other code, actually we usually say whenever we use the word heated or burnt with air, that means we're talking about oxygen. That means the element is reacting with oxygen. Here it is given zinc sulfite is heated in air, then the second part of it is zinc oxide and sulfur dioxide are formed. First of all, in the equation, if we see at the reactant side, it will be zinc sulfide plus O2. Make sure your symbols are correct, because for this you are going to get marks. This question is of 2 marks. 1 mark is for balancing and 1 mark is for the correct statement with correct symbols and everything is correct in it. So for this, we are going to write zinc sulfide plus O2 and then arrow. Now we will look at the product side. Product is zinc oxide and sulfur dioxide. We are simply going to write ZnSO4, that is zinc oxide, ZnO, not ZnSO4, it's ZnO plus H2SO4. Right? After it, in this way, we are supposed to complete the equation, and here we satisfy 1 mark. Now we'll come to the balancing part. For balancing, you're supposed to see at both the sides if the equation has equal number of zincs and sulfites. Because I can't write over here, I'm solving it in my notebook. You guys also solve it in your notebook and find the answer, like find the values required for balancing. You can pause the video till then. Alright, getting back to it. So when I reacted zinc sulfite with oxygen, I realized that we need 1.5 oxygen and then it's perfectly balanced. That is how we are going to do this, and rest of them is going to be in the ratio of 1:1:1, and that is how it will happen. So before oxygen, you are supposed to write 1.5 or 1 whole 1 upon 2 that. Now moving on to part 2, suggest one environmental problem involved with heating of zinc sulfite in air. Of course, there are so many environmental problems when we talk about heating. Sometimes they release carbon dioxide, sometimes they release carbon monoxide, but in this case, we see that it is releasing sulfur dioxide. Sulfur dioxide or SO2, right? So SO2 is like, it's a pollutant. I can recall that in the equation I told you H2SO4, if in case I had said so to sulfur dioxide. I'm really sorry, it must have slipped by my tongue, but I don't mean sulfur dioxide, I don't mean H2SO4, I don't mean sulfuric acid, but sulfur dioxide. In the equation we're supposed to write SO2. Alright, let's continue if in case, because I actually don't remember, but I can recall something like that. Anyways, coming back to this, SO2 is a pollutant and it causes acid rain, which is a huge environmental problem, and then it has its drawbacks, which we do not need to go a lot in detail because it's only a 1 mark. Moving on to part C, zinc oxide is reacted with dilute sulfuric acid to form aqueous zinc sulfate. Construct the equation for this reaction. Now, if we see at this question, it says us to once again construct an equation, and for this we're again going to make sure that we use the same marking criteria that we have used to write our answer before, like the way examiner marks these kind of questions of equations and related to all of it, related to equations and all. It is usually based on these 2 key points, especially when it's of 1 to 2 marks. Sometimes we are supposed to write state symbols as well, but I'm sure for O-levels it's not a must, unless it is mentioned in the question or mentioned in the part, or maybe the marking criteria tells you, like for example if it's of 3 marks or maybe 2 marks, and for 2 marks sometime in question they already give you the symbols, they already give you everything, and then you need to still satisfy 2 marks. So of course they're not going to remark you on what they have already given you in question. So for this, make sure you can click this, like there are 3 things that are really important for equation when it comes to chemistry equations, chemical equations. That is symbols, state symbols, and the symbols that are basically Zn and the periodic table element symbols, and then the formation, that is the same thing, that comes into the same category of symbols. Like these are the things that are supposed to be, otherwise your equation is wrong. Like if you make the arrow in the wrong direction, your entire equation gets wrong, of course. And then one more thing is balancing, which is really very important, and you must do it for every equation. I repeat, all the equations, balancing is a must, and correct symbols are must, and correct equation formation, basically that is what we call it. Alright, anyways, we had a long discussion on how to solve these equation based questions, but let's get back to the other one, that is part C. Construct the equation for this reaction. It will be zinc oxide, that is ZnO, plus sulfuric acid. Yes, here it is sulfuric acid, not sulfur dioxide. I'm getting a bit confused between them, but I hope you're clear now, because I tried my level best to clear it out. Once again, I apologize if I made any mistake above, because I really don't remember, and I'm shooting the video in 1 take, so of course I'm not going back into that video. But yeah, if there is any kind of issue of that sort, I'm really sorry, I apologize, and I hope now your confusion is cleared out. Sulfuric acid is H2SO4, then arrow, it will form zinc sulfate and water. Over here, if we see, over here we are not supposed to actually put any number for balancing the equation. We are not supposed to put that because the equation is already balanced in 1:1:1:1 ratio. And over here, if we see, this is already a 1 mark, and we can, like, it can click in your mind that if the question or equation is a 1 mark, so there is no requirement of further balancing it except writing the state symbol, except writing the symbols as it is. So that is why it is a 1 mark, because it's already balanced. Moving on to part D, pure zinc is made by electrolysis of aqueous zinc sulfite. Zinc forms at the negative electrode, hydroxide ion reacts at the positive electrode. Construct the equation for the reactions at both electrodes. Now, positive electrode, which is anode, over here the equation is going to be, I'm telling you with the whole balancing thing together. Remember, here balancing is really very important. Like, balancing is important. Even if you get it a 1 mark, balancing is important. But usually, sometimes exceptional cases might exist depending on which year you're giving the paper in, what kind of changes are there in the syllabus and in the marking criteria and all that. So we have these changes accordingly. So in the very same paper over here, we see this is a question of 2 marks, but here we're supposed to balance. Like I told you, balancing is a must. I told that to you above. So over here, we are supposed to balance for sure, even if it is of 1 mark, because without balancing, equation is like it doesn't exist. It's not practical equation if you use your common sense. Well, coming back to anode, so it is 4OH minus. That is the minus for the electron that is negatively charged. Arrow O2 plus H2O, that is 2H2O plus 4 electrons. Why 4 electrons? Because there is 4OH minus at that side. We need to balance the electrons. When it comes to cathode as well, you will realize it will get balanced and all that. If you want me to make a video over all of this balancing equation or this electrolysis balancing of equations, and you want me to give some tips and tricks over it, because these things basically work with tips and tricks. You don't have a lot of time to think in the examination. So you can basically comment in the section below and I'll definitely solve them. Then moving on to the negative electrode, that is the cathode. Over here it is simple. Zn2 plus 2E minus is equals to Zn. And here you get 2 marks if you write both of them correctly. If you write one of them correctly, you get 1 mark, of course. That's very obvious. Moving on to part E, zinc is used to galvanize iron to prevent iron from rusting. Explain how galvanizing prevents iron from rusting. Galvanizing is a very common trick used so that we can save the real metal and not destroy the base of anything. So for this, by avoiding it from rusting, so we usually galvanize it or put an additional layer over it that gets rusted or might get affected. However, the inner or the main, the main strength of it, the base of it doesn't get affected and the material stays strong. So for this, we do galvanizing, and galvanizing basically acts as a protective barrier. It protects the inner layer and it does not allow water, air or any kind of thing that rust. Basically, rusting is caused due to water and air. When they get together, it's rust that comes out. So yeah, it prevents it from reaching it to the base layer, that is iron layer. Then we can also understand that zinc reacts with oxygen and it loses electrons, and zinc is more reactive, alright, and it even reacts with oxygen. So of course it is the one that is going to easily get rusted first. Because if for instance, supposing if zinc was the inner layer and iron was the outer layer, and zinc was the base of that substance or that material, so what would happen is that iron would be saved from outside, but spaces that would be left where iron is not there, or even spaces, or even through somewhere, whenever it gets in contact with zinc, it is definitely going to rust it, and in that way rust will destroy the base and destroy the entire substance. So that is obvious that a more reactive metal must be on the outer layer. Now moving on to question number 8. A scientist investigates the thermal decomposition of calcium carbonate in a closed system. A dynamic equilibrium mixture established. What is meant by the term dynamic equilibrium? So for dynamic equilibrium, well, these are a few questions or a few terminologies that they asked in the paper. Like there are a list of terminologies that they would ask in the paper. If you want me, I'll give you the list in a video. Just all you need to do is let me know in the comment section below if you require it. I'll definitely make a video of it and take full advantage of the video, learn it and understand it very well. So yeah, coming back to the dynamic equilibrium. Dynamic equilibrium usually is always actually made when we are talking about reversible reaction, which has both a forward reaction and a backward reaction. I mean forward and backward reaction, that is what a reversible reaction is. And what happens basically when dynamic equilibrium is maintained, there is no changes in the concentration of the reactants and in the concentration of the products. So usually students get confused and they are like, concentration of reactants and products are equal. They are not equal. It is like highly impossible, like very, very, very rare chances are there when they are both equal and they are in dynamic equilibrium. But basically the concept about dynamic equilibrium is really simple, that once the reaction stops, or in one way the reaction is maintained, it is not stopped but maintained, like there are no changes in either reactants or the products when we talk about concentration. Moving on to part B, the pressure of the equilibrium mixture is decreased, the temperature of the closed system is kept constant. Predict and explain what will happen to the composition of the equilibrium mixture. So first of all, for this, simply amount of carbon dioxide will increase and there is going to be gas on the right side and not on the left side. That's all about this answer. It was a simple one. Moving on to part C, the temperature of the equilibrium mixture is increased. The pressure with the closed system is the pressure within the closed system is kept constant. The position of the equilibrium shifts to the right hand side. What conclusion can be made about the enthalpy change of the reaction? Definitely it is going to be endothermic because the temperature of the reaction is decreased. The temperature of the equilibrium mixture is increased, and when temperature is increased, so we are definitely sure it is about endothermic reaction. Moving on to part D. Calcium carbonate reacts with dilute nitric acid to form three compounds, X, Y and Z, or Z, whatever you call it. X is a salt, Y is a colorless gas and Z is a colorless liquid. Name Y and describe a test for this gas. Now let's hear the properties of the gas Y. It is a colorless gas for sure. If we first of all look at this equation, make sure you look at it. Make sure you understand it. Calcium carbonate is reacting with dilute nitric acid. When we talk about gas release, which is colorless, it's definitely going to be carbon dioxide because we're talking about a carbonate over here. And a gas will be released, of course, and if it is colorless, it is definitely going to be carbon dioxide. So that is Y. Then when we come at the test for it is pass the gas over a milky lime, over a lime water, and the observation will be milky lime water. Lime water turns to a milky form. Yeah, that is how I mean it. Anyways, part 2, name Z and describe a chemical test for this liquid. Here if you look at Z, Z is a colorless liquid. Because Z is a colorless liquid, and here we are reacting calcium carbonate with dilute nitric acid. And once again we're talking about something that is colorless and it's a liquid, so it's going to be water because water is also a product of this equation. Basically the products of this equation I'll tell you first of all. It is going to be calcium nitrate, carbon dioxide and water. That is how you must always remember that whenever these kind of equations come, our first priority should be that what products are going to be released or formed because of it. That should be the first priority, and then you can like write it down somewhere over here, and then later on cut it down, or it's not even important to cut it down. They won't really look at it. They won't really consider it, so you will write it over here, and then you see at the properties, and then you can match them, that what property matches what element or what compound that is formed in that way. So if we talk about this, water will be formed, that is H2O, simple water. A chemical test for it is that we can add copper to sulfate, and an observation to it will be that it will turn, the solution will turn from white to blue. That's all. Copper to sulfate will be added, solution will turn from white to blue. That's all you need to write for chemical test and observation. Usually I've seen students get confused about chemical test and observation, and they say they are almost the same questions. How do we divide what is to be written in what field? Simple. Chemical test is what you are supposed to do in the experiment, and observation is what you will see as an outcome of it. For example, as I talked about part 2, that is water. What are we going to do? We are actually going to add, or we are actually going to add basically copper to sulfate into water. This is our chemical test. But when it comes to observation, what we will observe is a color change, and that is white to blue. Make sure don't write simply a color change, but write what color change are you going to experience, you're going to see. Moving on to part 3, construct the equation for the reaction between calcium carbonate and nitric acid. As I already told you above, the products that will be formed. So calcium carbonate will react with dilute nitric acid, and here 3 compounds are already mentioned over here. One salt. Salt is calcium nitrate, CaNO3, and NO3 will be 2, plus CO2 plus H2O. That's like for the mark. And because I told you without balancing the equation it's impractical, like it can't exist in that form. In this form we have written, because if we see, so we have 2 hydrogens at the other side, at the product side, and we only have like 1 hydrogen on the reactant side. So we must put 2 before 2HNO3, and because NO3 is 2 already, it's all balanced. Simply what we have to do is put 2 before HNO3. If you want me to make a video on balancing, because balancing literally requires a lot of practice, but tips and tricks can actually make it way easier than you can imagine. If you want me to make a video over it, and you want to fasten your entire calculation for balancing, let me know. I'll make a video over it for you all, because of course we don't have a lot of time, so we can't think a lot. We can't put a lot of efforts into it in the calculation only for that 1 mark. But if we don't get that 1 mark, we might lose that 1 mark, and you don't want to lose a mark knowingly at least. So guys, yes, this is it for the video. We have 1 question left, and we'll solve it in the next video very soon. That would be the last video for sure. It's been a long way through this paper. I hope you found it fruitful. Make sure you leave your queries, feedbacks, everything in the comments below. Like, share, subscribe. Don't forget to ring the bell icon. And share the video with your friends. That's all. Thank you very much for watching.